Hello guys, this is Akash. Welcome back to Test Prep Card YouTube channel. In this video, I am going to discuss the applications of integrals, which is areas. These areas is the very important concept. That is, it is the application of integrals. That is, we have learnt integration already, so that you can check in the Test Prep Card YouTube channel playlist. But how to apply those integrals in order to find the area. The main motive of this video is this one. And I also explained in this video, I am going to explain the areas, how to calculate the areas in a simple way. There are so many shortcuts that are involved to calculate the areas. And one more thing guys, in the areas calculation, sometimes there are so many tedious equations will be formed. That is the variables will be formed in order to integrate. So we cannot integrate directly by using the areas concept. So that the definite integration concept will come into play. So we have to learn the properties of definite integration. So that is the reason this video I am making. And in this video, I will explain the areas completely shortcuts and what is area, how to calculate the area with respect to x-axis, y-axis, and in what is the area between the curves, and what is the area with respect to x-axis and y-axis, and how we can find the point of intersection, and what are the calculation simplifications, that is the shortcuts present in the areas. This thing is one part, and the other part I will explain what is the definite integration. That is slightly I will introduce because I already completed the definite integration. You can check it out in the Test Prep Card YouTube channel playlist. And one more thing I will explain, that is the properties of definite integration. By using those properties, you can solve the definite integration problem as well as the areas. How we can solve the areas? Just by making the integral positive, because the areas are never be negative and the areas never be cancelled. The areas should be only positive. So I will explain each and everything about the areas. So the main thing you have to understand is how to solve the areas by using the shortcuts as well as by using the properties of integrals. So that's it. Now let's get into this video and discuss the applications of integrals. What is the application of integrals? I already said what is an integral. Integral has many applications. Integral has many applications. You already know what are those applications. The first thing is we can solve differential equations. We can solve differential equations. And one more thing, we can solve areas. We can find areas. We can find areas. Yes, it is very important that we can find areas and we can solve the differential equations by using the integral concept. The integration I already discussed in the Test Prep Card YouTube channel. You can check it out on the mind map video. That is the integral I have discussed in the one shot. I think the entire mind map is discussed in that the important concepts like how to use the properties of different integration. In the here, I think the properties also given in this mind map. I will discuss these properties also so that you can understand how to solve. So this is very important session. You can find approximately plus 8 marks weightage through this session. Plus 8 marks weightage. Very important session. You can watch. It is very important guys. You have to watch very carefully. The integral is of two types, that is definite integration. Definite and indefinite. It is very important to understand what is definite and indefinite. The indefinite does not have any limits. The definite has limits. So where the application comes from, the indefinite integration can be used to solve differential equations, and the definite integration is used to solve areas, because in areas we have to evaluate the area between two numbers. That is, suppose this is the function, suppose it is not the integral, it is signed. I have to find area between these 2 points a and b, so that I have to integrate a to b f of x dx. Yes, so here the definite integration comes into play. But in integrate integration, I will solve the differential equations. So the differential equations are also completed, the integration also completed. You can check it out in the playlist. And if you didn't subscribe to this channel, subscribe to this channel to watch these amazing sessions, because these sessions will make you prepare very concise and very informative videos. These are all so that you can get the maximum benefit. And if you observe here the areas, what is meant by area? And one more thing, the area is positive always. The areas are added always. What is area? The area is how much amount of space that is it is occupied. Suppose if you want to evaluate the area of a rectangle, suppose this is length and this is breadth. The diagram is not neat. I can write, I can draw some more neat. But you have to understand the concept. Here, not the importance of the diagram. Here, the importance of the concept, that is area. Suppose if you think this is a rectangle, this is a rectangle of length L and breadth B. Yes, I want to calculate the area. What is area? How much space this entire rectangle has been occupied? How much space this entire rectangle have been occupied? In order to calculate, what I have to do? I have to multiply the whole length with whole breadth. Whole breadth I have to multiply. So if you observe carefully, this is the length, this is the breadth, this is the breadth. In order to find each and every particle, I have to multiply. Suppose if B0, B has some infinite points, that is B0, B1, B2, like this, so many points are there, so that it can form. So I have to multiply each line with this one, that is L with the B0, L with the B1. So if I take common L, it is a summation B1, B0, that is everything up to Bn. So it will be L into B, because this entire length will be B. So this summation, that is L into B0, L into B1, this will give an area, and this is the integration. This is the integration of this one. That is, this is the integration of limits B0 to Bn. That is, we have to integrate from B0 to Bn, and this entire length we have to integrate. This is said to be the area of a rectangle. I am just making you understand what is the importance of the area and how to calculate. That is, each line should be multiplied with the corresponding value of B, so that the entire area can be found. Like this, this entire area can be founded. Yes. So this is the main importance of area. But this is a rectangle. How we can find the area of a function? Suppose f of x is equal to x square. I want to calculate area. This is the function f of x, and I have to calculate how much area it is occupying. So from this, the concept of areas will come into play. Now, the area, in order to calculate area. But before that, I will explain one important concept. That is, what is the difference? What is the difference between definite integration and its application in area, and its application in area? What is the main difference here? If you observe very carefully, what's the integration of 0 to pi cos x dx? What is this integration value, and what is the area value? I am calculating area here, I am calculating integration value here, definite integration. What is the answer? If you observe very carefully, what is the integration of cos x? It is minus sin x. It is, I think sin x, I think integral sin x, it is minus cos x. Integral cos x, it is sin x, because when I differentiate sin x, I have to get, sorry, 1 second. Sin x differentiation is cos x, and cos x differentiation is minus sin x. So what function here? Here it is minus sin x. If I integrate minus sin x, the answer here, what we have to get? Here we have to get sin x. So I have to integrate cos x. So integral sin x is equal to minus cos x, and integral cos x is equal to sin x. Why? Sin x differentiation is cos x, and here minus cos x differentiation is sin x. So what is the answer? Integral cos x is sin x, not minus sin x. So sin x, pi 0 to pi. And if I apply the limits, it will be sin pi minus sin 0. Answer is 0. And what is the graph of cos x here? Cos x graph is like this. Cos, and the cos is 0 at pi by 2, and it will again like this. If you observe carefully, this is one area, this is one area, this is pi. I think this is pi here. This is pi. This is one area, this is one area. But if you observe very carefully, the integral is breaking at pi by 2. This is getting one answer, this is getting one answer. But when we are doing definite integration, this, suppose if I get value 1 here, this 1 is cancelling with 1 in the definite integration concept, because we have to break the limit at pi by 2, because it is becoming 0. So 0 to pi by 2 cos x dx plus pi by 2 to pi cos x dx. So we have to distribute the limit here, that is, we have to break the at one point, that is pi by 2, in definite integration. In the areas also we have to differentiate, that is, in the areas also we have to split, that is 0 to pi by 2 cos x dx, 0 to pi by 2 cos x dx, and one more thing, that is pi by 2 to pi cos x dx. Pi by 2 to pi, it is a cos x dx. If you observe very carefully, this is the splitting of the limits, that is 0 to pi by 2, it is 0 to pi by 2 cos x dx, and pi by 2 to pi, it is cos x dx. So if you observe very carefully, it is cos x and it is cos x. Yes, the function is same, but if you observe carefully, it is 0 to pi by 2 and it is pi by 2 to pi. The main important thing is at what point we have break the limit? We have break the limit as pi by 2. So the function, you already know, this is like this. Yes, we have break at pi by 2, but this is the negative. Suppose it is 1, it is minus 1 we are getting after integration. So this is 1, but areas, what I said in areas concept, that there is no subtraction of areas. Always the area should be added. So it will be minus of minus 1, because we have to take here minus, because it is a down, that is a below graph. Suppose if you are calculating the above graph, it is 1, but if I calculate the down area, it will get negative in the definite integration. That thing we have to make positive. Yes, so it is a minus. We have to take minus here, but here there is no minus. We have to take plus here. So the answer here is 0, but the answer here is 2. This is the main reason why some people calculate area as 0, because they will just subtract the above area and below area. But areas are not subtracted, the areas are always added. That is, the above area if it is 1, the below area if it is minus 1. But what is the definite integration values then? The above will be 1 and the below will be minus 1. If normal definite integration is performed, it will be 1 minus 1, it will be 0. But when area is performed, that is, in order to calculate area, it will be 1 minus of minus 1 we have to do. This thing is very important, because areas cannot be subtracted, areas should be always added. And I have explained up to now the main thing, and the next thing is area. We can calculate area. We can calculate in two ways. Area we can calculate in two ways. The first way is area with x-axis. We have to calculate area with respect to x-axis. That is, this is a x-axis. Suppose this is a curve, and we have to calculate area from A to B. That is with respect to x-axis. That is, with respect to x-axis, we are calculating its area. This is area, and we are calculating with respect to axis. How the formula will be? That is, integration will be same, and the limits are same. That is A to B. Now here, what will be the answer? We are calculating with respect to x, it will be dx, but here the value will be y. Why? Because we are dealing with the x-axis. How we can get the expression in x? Suppose the function is y equal to x square. We have to calculate with respect to x-axis. We have to substitute y is equal to x square here, because we are dealing with the x-axis area. So the expression should be x. That is in the terms of x. So when the terms will be in the terms of x, it will be y. That is integral a to b y dx. So this is area with respect to x-axis. What is the area? What is the area with the y-axis? Suppose the curve is like this. And these points are A and this point is B. Now if you observe, it is A to B only, but here, in order to find the y in terms of x, we have to write x dy. So integral y dx will give area with respect to x. Area with respect to x, and integral x dy we give area with respect to y. These things you have to remember. That is, what is the integral y dx will give? It will give area with respect to x-axis. And what is the integral x dy it will give? It will give area with respect to y-axis. These are the main important points. And suppose if there is an integral which is like this. Suppose there is an integral which is like this. That is like this. Or if it is like this, what we have to do? We have to pre-subtract this. Suppose this point is A, this point is B, and this point is C. This point is A, this point is B, this point is C. Suppose I am calculating with respect to x-axis. What I have to do? The function is f of x. First of all, I will mention the function. If you observe carefully, I am dealing with the below x-axis. So the area will itself receive a negative sign. I am not keeping it because it is other thing. I am just making it is positive. Definitely the definite integration will become negative because it is below x-axis. See, in order to make definite integration as positive and to calculate the area, I am pre-using negative sign. The negative of sign, and I am dealing with the a to b, and the function is y dx plus I have break the limit in b, and again b to c f of x dx, which is y dx. Yes, this is the main thing here in this graph. But what about this graph? In this graph, a to b is positive, but b to c is negative. So a to b f of x dx minus, we have to again subtract minus integral b to c f of x dx. Why I have taken negative in the first here and I have taken negative in the second here? Because the after splitting limit, that is after splitting the limit, it is becoming negative. But here before splitting the limit only it is becoming negative. So we have to use negative before, here we have to use negative after. This is the main important thing. Like say this same thing, this also like this, or you can say this one. If you observe carefully, it is A, it is B, it is positive, but here if you observe, it is another thing. That is, suppose it is below. I think the graphs are not like this. 1 second. I am giving examples. So when we give examples, those examples need not to be always correct. They can be wrong, but it will make you help to understand the concept in an easy way. Suppose this is like this, and the curve is like this. The curve is like this. Or you can take example, wait, I will give the perfect thing. With respect to y-axis, you have to calculate. This is area. This is area. I think I can draw the better graph. 1 second. Yes, now comes the perfect graph. This is the area. Yes, if you observe the point, it is, suppose this is not origin. Suppose let's assume it is not origin. It will be A, it will be C. The above, that is positive y-axis graph, will be positive. This will be negative. We have to assume like this. So what is the main important thing? When I evaluate A to B, it is f of x or it is x. It is x dy plus integral b to c x dy. Very important thing. This is wrong. Why? It is negative, I already said. So pre-negative should be there. So now becomes the final answer. So this thing should be negative before only, because this is the negative y-axis graph. So the negative y-axis graph will result in negative area. That negative area will be added to the final result. That result will be wrong, because in that result there is an error. Why there is an error? Because the area is subtracted, but the area should not be subtracted. The areas always should be added. This is the final result. Now it becomes a correct. Now it becomes a correct. This is the thing. Now I am discussing again important concept, that is area between two curves, which is an important concept. Area between two curves. How to calculate the area between two curves? The main important thing here is, suppose there are two curves. Like this, there are two curves. The curve here is f of x and the curve here is g of x. Yes, if you observe very carefully, the main important thing in the question, they give f of x and g of x they will give. When f of x and g of x, two functions will be given, what you have to do? We have to find the point of intersections. That is, point of intersection should be found. When we find the point of intersection, suppose that points are A and B, then what is the procedure? The procedure here is, we have to subtract and find. That is, the value should be subtracted. That is, the integration should be A to B only. A to B, but here, what is the value you have to write? Here it will be dx only, because we are treating with respect to x. So it will be dx. What is the value in between here? The value here is the upper curve minus lower curve. Upper curve minus lower curve is the answer. That is integration A to B. What is upper curve here? Upper curve is this one, that is g of x. G of x minus f of x into dx is the answer for the area between two curves. Area between two curves, f of x and g of x. It is very important. The upper curve minus lower curve is the answer. Now, it is with respect to x-axis. What if there is a y-axis area? Suppose the area is like this one, and if you think this one, if this is two, these are two areas. This is the first curve f of x, and this is the second curve g of x. Suppose. Now in this case, with respect to x-axis, what we discussed, it is the integration from a to b, upper curve minus lower curve dx. Yes, but with respect to y-axis, how it changes? It is same a to b, and it will be dy now, because with respect to y-axis we are calculating. Now, in order to calculate the area, the curve, again we have to find the point of intersection. The point of intersection I am assuming as a, and here it is b. That is a, and here it is b. I am taking the area from a to b only, but here not upper minus lower, because the curves are present at right and left. So the right minus left will give the area. That is right minus left. That is the right curve minus left curve will be the answer. Right curve minus left curve will be the answer. So this is the main important thing you have to understand. That is, when there is an area between two curves with respect to x-axis, the upper curve minus lower curve will give the area. But when it is present with respect to y-axis and right is present one curve and then left it is present in another curve. So in that cases, we have to subtract the right curve minus left curve, and we have to take the limits a to b, and that a to b limits are those limits which came from the point of intersection of those curves. It is very important. Suppose y equal to x square is a curve, and another curve is x is equal to y square. Suppose these two are the curves. That is y equal to x square, this is a curve, and x square is equal, this curve is y is equal to x square. This curve is y square equal to x. If you observe this thing, I have to calculate the area between the curves. Suppose I am dealing with respect to x-axis, I have to calculate the point of intersection. One point is 0, 0. What is other point? What is other point? That is I have to evaluate. That is I can substitute here in the place of y, I think. What point I will get here common? Two curves, y equal to x square, another curve is y square equal to x. One point is 0, 0. It is very obvious. What is other point? I think it is x power 4 minus x equal to 0. If I take common x, it is x cube minus 1 equal to 0. One thing is x equal to 0, another thing is x equal to 1. So when equal to x equal to 1, it is 1. So it is 1, 1. If you observe it, 0, 0 and 1, 1 are the points. If you observe the x values, it is 0 and 1. It is 0, it is 1. So if I want to calculate this area, what I have to do? I have to integrate from 0 to 1, and the upper curve minus lower curve. What is upper curve? Upper curve is y square minus x. That is y square equal to x. So what is y? I have to find in terms of x. So it will be root x minus, what is the lower curve? It is y equal to x square. So it will be x square whole dx. Yes. Now solve. What is the integral of x? It is x power 3 by 2 divided by 3 by 2 minus, what is x square? It is x cube by 3. So this is the value, and substitute the limits 1, 0. What you will get? You will get 2 by 3. 2 by 3 minus 1 by 3 as one answer, and if I substitute 0, both will be cancelled. That is 1 by 3. So the answer is 1 by 3 here. So the area is equal to 1 by 3. The area is equal to 1 by 3. That's it. And if you observe y square equal to, I think it is 1 by 4 value of a, here also 1 by 4 value, 16 AB, that is 1 by 4 into 1 by 4. And there is a shortcut to calculate this area. That is the reason I am taking 1 by 4, 1 by 4. What is 1 by 4 and 1 by 4 here? What are the two curves given? Y square equal to 4ax, one curve is given. Yes? Y square is equal to 4ax is one curve, it is given. And x square is equal to 4by, another curve is given. What is 4a here? If I compare with the given equation, 4a is equal to 1, a is equal to 1 by 4. And what is b here? B is equal to 1 by 4. There is a formula to calculate the area, that is short trick. Short trick to calculate this area, that is bounded area. What is the formula? That is 16ab by 3. If I substitute the a and b values, what I will get? 16 into 1 by 4 into 1 by 4 divided by 3. This thing will be get cancelled. Answer we got 1 by 3. So without any integration, I find the area 1 by 3. So this is the importance of area, so that you can create so many shortcuts. This is the thing here, and now I will discuss those shortcuts only. Shortcuts. I will discuss those shortcuts only for calculating the area or area. What are those shortcuts? I will discuss one thing, that is area of triangle. What is area of triangle? You already know. That is half into length, that is half into base into height. This is one shortcut. You already know this is not shortcut, but this is a shortcut in calculating area. Suppose the graph is like this, and you have to calculate 1 to 2, and this value is this length is 1. Easy, that is half into what is base, it is 1, and height is 1. Yes, so it is half, area is half. There is no need to do integration. And the second thing is area of trapezium. You have to use these logics. Trapezium. What is area of trapezium? It is half into sum of parallel sides. Sum of parallel sides multiplication distance between them. This is the answer. Distance between them. This is area. Suppose this is a trapezium, and the parallel sides are 3, 4, and the distance between them is 5. What is the area then? Half into sum of parallel sides. It is 4 plus 3, it is 7, and distance between them is 5. That is 35 by 2. That is 17.5 is the answer for this area. Like this you have to calculate. And next, if I discuss the third one, that is area of a sector. Area of a sector. Direct formula. The area is equal to half of theta r square. This is area. Just remember. And next, fourth one, that is area of a standard ellipse. Area of standard. What is area of standard limits? The area of standard limits is pi AB. That is pi AB. You already know what is ellipse. I will discuss in the ellipse chapter in the mind map series of test step card. This is ellipse. This ellipse area, entire area, is equal to pi into AB. And if I want to calculate this area, it will be pi AB by 4. You have to understand very carefully. Now, area between two parabolas. I will discuss what is parabola in the mind map series of test step card only. It is a geometry portion. I will discuss there. Area between two parabolas, but I will give the glimpse of parabola. The parabola is nothing but this one which we discussed earlier. This is a parabola of one type, and this is a parabola of one type, another type. If I merge these two, what I will get? I will get this type. And if I want to calculate the area between two merged parabolas which having the common vertex, and intersect at another point, that area is equal to, I already discussed, that is 16 AB divided by 3. This is the answer. And suppose now I want to calculate the area. Bounded by the area bounded by the line and the parabola. If I want to calculate this area, what I can do? That is, they are saying this one. That is, if this is the parabola and this is a straight line, I want to calculate this bounded area. This area I have to calculate. This entire area, if I want to calculate, what I can do? I can use a shortcut, that is 8a squared divided by 3m cube is the answer. That is, if this parabola is equal to y square equal to 4ax, the a value will be this one, and the m value will be the line which you are discussing here, that is y equal to mx plus c. The slope, we can directly substitute. Suppose if I given y square equal to 4x is a line, y square equal to 4x and y equal to x. This is a parabola, this is a line. If I want to calculate the area bounded between these two, what I can do? I can simply use 8a square divided by 3m cube. Otherwise, I have to solve these two, and I have to calculate the point of intersection. Then I have to apply the limits with respect to x-axis or with respect to y-axis. There will be lot of disturbance. From that also you will get answers, but it will take time. In J-Mains, each question will having approximately 1 to 2 minutes only. So 1 to 2 minutes you can do this one within 30 seconds. So within 30 seconds, if you get answer, why to go to long process? So just go to simple process and find answer. But anyone who is learning the shortcuts should have the concept of the long methods also. That is 8a square divided by 3m cube. What is a here? A is 1 here. Yes. Compare y square equal to 4ax. What is a value? A value equal to 1. So 8 into 1 divided by 3m cube. What is m cube here? The m value is equal to 1 because it is comparable to y equal to mx. So m is equal to 1 here. So when I substitute, it will be 3. That is 3 into 1, it will be 3. So the answer is 8 by 3. Simple area, we got 8 by 3. Otherwise, we have to find the point of intersection. We have to take the respective limits by using the point of intersection, and we have to calculate the area. That is upper curve minus lower curve with respect to x-axis, or if I want to calculate with respect to y-axis, again right curve minus left curve. It will be very tedious. And I think I have explained the shortcuts. Yes, this much only. This many shortcuts are only present in areas. So the areas concept is completed. I have discussed some examples also. It is completed. Now I will explain the properties, how you can solve the limit integrals in an easy way. This thing is completed, this thing is completed, and I think the area enclosed, yes, this thing also completed. These 3 blocks are completed, but these examples I have discussed. Yes, 3 blocks have been completed. Why not I am explaining by seeing this one? Because if you directly read this one, you cannot understand anything. That is the reason each block I am explaining as a concept, so that after explaining the block, after seeing the block, that is after explaining the block, and later if you see this block again, it will be easy to grasp. That is, if you see the first block, the area of the region bounded by the curve x-axis and the lines x equal to a. This is the graph there. I already explained. That is, if this is a curve which is having the limits a to b, if I want to calculate area, it is simply a to b f of x dx. So after seeing of the explanation, it will be easy to grasp the block. That is the reason I have explained the concept first, and after seeing the block, I have said that it is completed. The reason is it is completed because I have explained, and I have taken the example also. If you see here, this block, the area of the region between two curves, that is, if the graph is like this, that is upper and the lower, if both are intersecting at certain points, what is the area? I will draw neatly. Suppose this is a curve and this is a curve, another curve. If I want to calculate the area between, I already explained, it is a area of A to B, that is a point of intersection of A to B, and it is upper curve minus lower curve into dx. This is the main logic to explain the concept first, and after explaining the block. So I have explained this one also. This one also, this is the properties. This is the properties. That is, they are saying if f of x greater than or equal g of x, that is f of x function is greater. So if f of x is greater, then what we can do? We can calculate the area, that is a to b. That is, if it is f of x greater, then it will be very high than the g of x. So a to b, f of x will be first minus g of x. And I already said the integral can be splitted. That is, it can be distributed. That is a to b, f of x. Don't forget to write dx. F of x dx minus integral a to b g of x dx. This is the thing the block is explaining. This thing also completed. 1, 2, 3, 4 blocks is completed. Now I think 1, 2, 3, 4, 1, 2, 3, 4, 5. Only 5 blocks are having in this mind map. I have already explained the 4 blocks. Now comes the important thing. That is the properties of definite integrals. This thing I already explained in the definite integration. But here again they given. The main reason to give again this one is to calculate the areas. Sometimes it is very tedious to calculate the areas. Here I explained the simple examples, that is x square, x cube, that is a parabola and a line. What if it involves a trigonometric functions? What if it involves exponential, and if it involves a signum, or if it involves the greatest integer fractional part? If the areas are like that, we have to use the properties. If the properties are known to you, it is very easy to calculate the definite integration. And if definite integration is solved, and if we check the down area and above area, if it is down area, if I keep the minus sign, then it will become the area. So the first and important thing you have to learn is definite integration. After definite integration, but before definite integration, you have to learn the indefinite integration. So the combined thing I already explained, so that if you learn that one, it will be easy for you to grasp the area concept. So what is area concept? This is the application of definite integration only. But while calculating, you have to check whether the area is below the x-axis or it is below the y-axis. If it is below the x-axis, we have to pre-negative it. That is, we have to make it positive. The area should be positive. So that we have to make it positive. The area, I think the area cannot be negative. If you are getting the value negative, you are doing something wrong. The area is always positive. The negative area will not be there. The zero area can be there, but I think the zero area can never be there, because if they require to calculate the area, if there is no area, why they are asking to calculate the area? So you have to understand the logic here. If they are required to calculate the area cannot be negative and zero. The area is always positive and it has some value. Suppose if you are calculating this area, there is an area. So 0 cannot be the answer and negative cannot be the answer. So the area should be always positive. If there is no area, suppose these are the collinear points, and they are saying that these points, they will not say these are collinear points. These points are making a triangle. That is, these points will not make a triangle, but we have to calculate the area. If they are saying like that, what you have to do? There is zero area, because the points are collinear. In that cases, it can be 0. But what if they will say it having the area and you have to calculate? Then we have to apply the indefinite integral formulas or properties. I will explain each and every property. You have to understand very detailed. Now I will explain the properties. Properties of definite integration. It is very important. But before learning definite integration, you have to learn what is indefinite integration. Indefinite integration you have to understand. Very important. What is indefinite integration? Integration without limits is called indefinite integration, and integration with limits is called definite integration. If this answer is f of x, this f of x plus c, this answer is f of x only, but we have to substitute the limits. Now the answer becomes f of b minus f of a. Very important. This is a just difference between the indefinite and definite. But to solve the definite, you have to solve the indefinite only. After solving, at last you have to substitute the limits and find the answer. This is a definite value. That is the reason it is called definite. This c can be anything, that is a constant, so it cannot have a definite value. It is indefinite value. That is indefinite integration. Indefinite integration. So now the first property comes. What is the first property? You already know what is a to b f of x dx. The answer is capital F of x and the limits a to b, and the answer is capital F of b minus f of a. Yes, and the second property is we can change the variable. That is f of x dx can be changed as integration a to b f of t dt. That is the variable can be changed, because in the indefinite integration the variable has no role. It is just the varying limits. But at last, if any variable, that is t, s, anything, at final we have to substitute limits only na. So at substituting limits, the variable is not the main thing. But in the indefinite integration, the variable makes sense. That is, if there is t into x into dx. Suppose this is like this. If you observe, it is dx. So it is that the integration will be with respect to x. So t is a constant. So we have to eliminate. It will be t into x square by 2. Yes. So the variable will having the role in the indefinite only. But in the definite, the variable can be interchanged. That is, if it is x and dx, I can change it to t and dt. This is a property of the definite integral. And the third thing is I can reverse the limits. Suppose if it is f of x dx, from a to b, I can write it as b to a also. But there is a negative sign in the outside. F of x dx. This is a main important property. And now comes the important properties. That is a Katapa and Bahubali. It is the given mnemonics like that, but there are important properties here. That is, suppose if the integral is a to 2a f of x dx, this can be is equal to 0 to a. That is, the 2a will become half. This is called as Katapa property. Don't take in another way, because we have to give mnemonic, because these properties are really important. 0 to 2a f of x dx can be splitted into 0 to a f of x plus f of 2a minus x whole dx. This is an important property. This is an important property. You have to understand. I can give it to 5-star also, because so many questions have came. And one more thing I have to say, guys, the indefinite integration, definite integration, which one having the high weightage? It is obvious indefinite integration, but in the recent years, the definite integration have gained so much weightage. That is, indefinite integration, some ships cannot having any question. They are giving only definite integration questions. So you have to understand how important is definite integration. But definite integration, if you want to understand, you have the high concept. That is, we have to dedicate a very high amount of time in the indefinite integration, because it is just the application of limits only in the definite. You are not learning any other concepts, but you are learning here properties, but you are not learning any other concepts than the indefinite integration here. You are just learning the simple properties and the periodic properties here. That's it. You are not learning more than the indefinite integration. But in the indefinite integration, you have learned how to solve an integration by thinking of what is the substitution, what is the method we can obtain. Because indefinite integration we can solve in many ways. That is by using the partial fractions, by using the integration by parts method, by using the substitution method, anything. In the indefinite integration, it has a vast syllabus. But the definite integration is the substitute of the indefinite with the limits. That is, I can say indefinite is subset to definite. that is the definite is the bigger, because every concept of indefinite comes in definite, but here just the limits will be coming. The limits will be coming. That's it. I have discussed the Katapa property. Now comes the Bahubali property. This is set to be, this is called as Bahubali. The names can be different. Here it is becoming half value. That is the reason it is set to be Katapa, and the property can be Bahubali. Suppose if it is minus a to a f of x dx. Suppose this is the integral you have to solve, minus a to a. I will take one example at the last. You can understand minus a to a f of x dx can be found. And what is the answer here? The answer can be two types. If f of x is odd, the integral minus a to a f of x value will be 0. The entire angle will be 0. That is, entire integral will be 0. But here, if f of x is even, this entire integral, that is integral minus a to a f of x dx, is shifted to 2 times integral 0 to a f of x dx. Very, very, very important. This is a property. And next comes the periodic properties. Periodic properties. The periodic properties are explained, I think, here. The periodic properties are these properties are already explained. And sorry guys, one more property I have forgotten. The property is, here on I will explain. The property is, what is integral 0, that is a to b f of x dx. How you can evaluate? It can be written as a to b f of a plus b minus x into dx. This is the answer. That is, you can add the limits and subtract the minus x, because you can entirely substitute this as t and this as t. If I substitute again, after substituting and evaluating, I can change this as f of x and dx. So these two are same. These two are equal. These two are equal. Now comes the periodic properties. The first periodic property is, what if the integration is 0 to nt f of x dx, where t is a period. I can write this as n into integration 0 to t f of x dx. This is an important property. And what is the question? It will be like this: a plus nt f of x dx. It will be, a will get cancelled. It will be 0 to nt f of x dx. And after this, it will be n into 0 to t f of x dx. Yes. And what if the question that is it will be like this, that is a plus mt b a plus nt. If it is like this, the question, a will get cancelled, and our final answer will be I think it is upper minus lower, it is n minus m, that is the cycles n minus m integral 0 to t f of x dx. 0 to t f of x dx. These are all called periodic properties. Periodic properties in definite integration. And why are discussing in the areas, that is application of integrals? Because in areas we have to solve integrals only, that is definite integrals only, but there we will get the area. In the definite integration you will get the integral value, but here you will get area. If definite integration gives a negative result, we make it positive and we will denote it as area here in this area chapter, that is applications of integrals. And I think I have explained properties, that is this thing. These properties I already explained. I have explained these properties. Entire properties have been explained, and the periodic properties are also explained. Yes, periodic properties are also explained. And here they given one important point, that is, if f of x greater than or equal to 0 on the interval a to b, then a to b f of x dx is equal to greater than or equal to 0. Yes, it is correct. If f of x less than or equal to g of x on the interval a to b, here the property is not given. But I already explained, that is a to b. If g of x is a greater function, if I do f of x minus g of x, what I will get? F of x greater function, it will get positive. But what if g of x is greater? G of x greater than f of x, you will get this one. A to b f of x minus g of x will be having two values. The first value, if f of x greater than g of x, this integral, this entire integral will be positive. Yes. And if f of x is less than or equal to g of x. If g of x is greater, the negative will be making the entire integral as negative. This is the main important thing you have to understand. Now I will discuss some problems, that is the examples which are there. I will discuss so that you can understand how to apply. The first question is question is 0 to pi. I am these questions are not present in the mind map, but I am discussing. The main reason is I have discussed the concept so that you can understand how to apply. But really how to apply, you have to understand from the questions. So 0 to pi root of 1 plus cos 2x divided by 2 into dx. This is the question, and the options are 16, 2, 32, and D option is 4. Now solve this one. How to solve? They are given 0 to pi root of 1 plus cos 2x by 2 dx. First of all, don't see the properties. Whether you can simplify this, first of all, see that 1 plus cos 2x is equal to 2 cos square x. You already know this. So simply apply this one. So 0 to pi, yes, 0 to pi root of 2 cos square x divided by 2 dx. 2 will get cancelled and you will get 0 to pi. 0 to pi, how much? It will be cos x dx. And cos x dx, 0 to pi, answer is 0. But 0 is not the answer. Why? It is cos square x, that is root. When you solve, you will get modulus, that is 0 to pi. This is wrong. Why? You will get mod cos x into dx. Mod cos x. And how mod is opening? It is the main important result. 0 to pi. If you observe mod cos x graph, it is a graph this one. 0 to pi, this is 0, this is pi by 2, this is pi. So this area is 1, this area is 1. So this value will get 2 as answer, not 0 as the answer. It is very important. It is very clear in the options only, they didn't give any option 0. So option is B. So like this you have to solve. Why I taken 0? Because that is why I taken mod cos x, because under root term anything should be positive. That is, what is under root of x square? It is mod x, not x. It is wrong. It is mod x. So you have to understand. And the next question is minus 1 to 3 tan inverse x divided by x square plus 1. These questions what I am discussing is the previous year questions of JEE mains. And the options are pi, 2 pi, option 3 is 3 pi, option 4 is 5 pi by 2. Now solve the question. You can pause the video and solve the question. This integral you have to solve. Suppose this is the area only we are finding. Suppose what we have to do, we have to use the properties of definite integration, but wherever you are getting negative, you have to make the positive. That's it. This is the integral I am solving because you have to apply the properties. We have to apply the properties. So when you see here minus 1, can I split the integral to minus 1 to 1? Yes, minus 1 to 1 tan inverse x divided by x square plus 1 plus tan inverse x square plus 1 divided by x. Yes, I can split this entire thing dx. Again, I can write another integral, that is from 1 to 3 now. That is tan inverse of x divided by x square plus 1 and plus tan inverse of x square plus 1 divided by x and whole into dx. If you observe, I have splitted the integral at the point 1. Why I splitted? After seeing the minus 1 here, because I have no minus a to a property f of x dx. It having two values. If f of x is odd, this integral is 0. And if f of x is even, I can write as 2 integral 0 to a f of x dx. For that reason I have splitted. So if you observe minus a to a, when you keep here in the function minus, this entire thing will become minus of f of x. When f of minus x will be given, you will get minus of f of x. So what type of function it is? I already explained in the sets relations of functions. If you want to find, you will go in a test web card playlist, you will find that mind map. So that way I discuss why f of minus x is equal to that is f of minus x equal to minus f of x is called as odd function. I have explained there. It is odd function. So this is odd function. So this entire thing will become negative. So when it is odd function, the answer is 0. I already explained in the properties. So this is the importance of properties. This entire thing is equal to 0. Now I have to evaluate just this one. Now I am seeing this one. What is the answer? Simply see 1, 2, 3 tan inverse x divided by x square plus 1 it is given, plus tan inverse x square plus 1 divided by x into dx. It is given like this. Yes. Now if you observe, you already know this property. What is tan inverse of x? Can I write cot inverse x here? Cot inverse 1 by x when x is greater than 0. Yes, there is a property. I explained this property in the trigonometric functions, that is inverse of trigonometric functions. You can find the lecture in the playlist section of test prep card. That is tan inverse x equal to cot inverse 1 by x, and again I can write tan inverse 1 by x as cot inverse x. By this property only x greater than 0. So here if I consider this x as greater than 0, in the question only they given, can I write 1, 2, 3 tan inverse x divided by x square plus 1 is same, but can I write this one as cot inverse the reverse of this, that is x divided by x square plus 1. Yes, whole dx. Now again if I see this one, it is tan inverse x plus tan inverse, sorry, one second. It is again resembling the property of inverse functions, that is tan inverse something plus cot inverse something. This something is same, should be same, very important, same. And what is same here? X divided by x square plus 1. So this entire thing that is tan inverse x divided by x square plus 1 plus cot inverse x divided by x square plus 1 will become pi by 2. So I can write as 1, 2, 3, that is from limit 1 to 3, this entire thing will be equal to pi by 2 dx. Yes. So what is the answer now? Pi by 2 is a constant. By the property of a to b, k times dx can be evaluated as k integral a to b 1 dot dx. So by using this property, I can write this as 1, 2, 3, that is pi by 2 I have taken outside, and it will be 1 dx. So what is the answer? Pi by 2 into, what is the integration of 1? The integration of constant is x. Because the integration is with respect to x, we are getting x. If it is with respect to t, we will get t here. And after finding the integrations, just substitute the limits. Pi by 2, and when we substitute this one, what you will get? You will get, first of all, 3 will be substituted as upper limit, and next to the lower limit will be substituted as 1. And what you will get? You will get pi by 2 into, what is 3 minus 1? It is 2. 2 will get cancelled, and the answer is pi. Answer is pi. This is the main important thing. So I think where are the options? Here are the options. So answer A will be there. Answer A will be there. So this is the main important thing. So I think I have completed. This block is also completed. This block is also completed. So I have explained entire applications of integrals. That is these concepts. I think the blocks are completed. There are 1, 2, 3, 4, 5 blocks. This block is completed. 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 So 1, 2, 3, and 4, 5. 5 blocks I have completed. So the main theme of this video, that is the main motto of this video, is to explain to you how much importance is integrals and the application of integrals, which is areas I have discussed here. So if you like this video, subscribe to this channel and also hit the bell icon. And if you have any queries, you can write it down in the comment section of this Test Prep Card YouTube channel. And also you can watch other sessions of maths, physics, chemistry in the playlist section. You can go and check it out. So that's it for this video, guys. And thank you, guys. And keep learning and keep going.